Hi friends, hope you all are doing good. So today we will discuss buffer solution. So what do you mean by buffer? So there are some solutions that resist the drastic changes in the pH when small amount of strong acid or a base is added to them. Now what it means? Like there are few solutions when you add small amount of acid or base to it, they will the pH of that solution won't change. It will remain constant provided you are adding very small amount of acid or any strong base. So we call such solutions as buffer. So human blood is also a buffer which maintains the pH at 7.4. I hope this definition is clear. Now, buffers are of two types, acidic buffers and basic buffers. So now what are acidic buffers? So acidic buffers are made, so we will mainly focus on acidic buffers. So they are made up of weak acid, like we have to take a weak acid plus salt. So which salt? Salt of weak acid and strong base. Strong base. Can you think of any salt made up of weak acid and a strong base? Let us take weak acid as acetic acid and salt to be weak acid. So weak acid is like acetic acid, and strong base is sodium hydroxide. So which salt they will form? They will form sodium acetate. So CH3COONA. So this is a salt of weak acid and a strong base. So when you mix them together, these two, they will form a buffer solution. Similarly, another example is H2S, which is a weak acid, plus salt K2S. K2S is made up of which two which two things? Let us take weak acid as H2S plus potassium hydroxide. So potassium hydroxide and this acid, when mixed together, they make up this particular salt. So this also forms a buffer. So now how to calculate the pH of buffer? I will tell you a very simple equation which relates the pH of the buffer. So pH of the buffer is basically equal to pH equals to pKa plus log base 10 salt concentration divided by acid, concentration of the acid. Now what is this pKa? So how to find this pKa? pKa is basically negative logarithm of Ka. Ka is your dissociation constant of an acid. I hope you know what is Ka. So this is so this is for the acidic buffer. Similarly, we have a formula for the basic buffer. Basic buffer is equals to, so for the case of basic buffer, we don't have pH, we have pOH. So pOH equals to pKb plus log salt divided by acid. So how pOH and pH are related? pOH plus pH equals to 14. Okay, so these are three equations. So this equation, and this equation. So we will be focusing on the acidic buffers. Fine. I hope this is clear. Just learn this equation. It will be really helpful for you. And what is pKa? pKa is negative log base 10 of Ka. Okay, fine. Let's move further. Okay, let us solve this question now. So what it says, a buffer solution contains this much moles of sodium ethonate in a solution of 750 ml or centimeter cube of 0.05 mole per decimeter cube of ethanoic acid. The solution is at this. Calculate the pH of the buffer solution form. So Ka value is given. So this is a 3-mark question. Let's do this. Okay. So basically, first of all, if you see here, they have given us the moles. But what we have in the equation, we have the concentration. So we need to find the concentration first. How to calculate the concentration? So concentration of sodium ethonate. What is sodium ethonate? CH3COONA. So this is the formula of sodium ethonate. The concentration of sodium ethonate is, how to calculate? Moles, basically moles, 0.05 divide by volume, which is 750 times 1000. So you can calculate the concentration, which will come out to be 0.06 mole per decimeter cube. Fine. Okay, now we have Ka value. So we can calculate pKa. So what is the pKa? Negative log 10 of Ka. Okay, negative log. What is the Ka value? Ka value is this much. So which is 1.76 into 10 to the power negative 5. So we have to solve this. So simply put it in your calculator and you will get pKa value as 4.754. So this is your pKa value. Okay. So we can take it as 4.75 only. Okay. So now we have pKa value. Now let us calculate the pH. So what is the equation of pH? pH is equal to pKa plus log concentration of your basically concentration of your salt form, which is how much concentration is of salt. Okay, let me write the equation first. Salt divided by acid concentration. Okay, so what is the concentration of salt? Let me do it here. So pH equals to pKa is 4.75 plus log concentration of salt is, we have calculated 0.06. And what is the concentration of acid? So it is given in the question. Read it. 0.05 mole per decimeter cube of ethanoic acid. So 0.05. Correct? I hope this much is clear to you. Okay. So pH equals to 4.75 plus solve it log 0.01. Okay, it would be log 1.2. So pH equals to 4.75 plus 0.0791. So it is pH comes out to be 4.829, round it off 4.83. So this is the pH. I did nothing. I just used this equation. So divide the concentration of salt by acid, take the log, calculate the pK value. How to calculate the pK value? This is the formula to calculate the pK value. I hope this question is clear. Now let's move to the other question. Okay, so let us do the next question. Okay, so it says a buffer solution containing 1.2 mole per decimeter cube of sodium ethonate salt and an unknown concentration of ethanoic acid is found to have a pH of 4.9. What is the concentration of ethanoic acid given that Ka is this much? So they have given us the Ka. Again, what to do? Basically, use this equation again. pH of a buffer is equal to pKa plus log salt divided by acid. Okay, so we have to calculate this concentration of ethanoic acid, which is this. So we have to find this value. Okay. Yeah. So first of all, let us calculate Ka value. So what is pKa? pKa is negative log Ka. So negative log, what is Ka value? 1.76 into 10 to the power negative 5. Okay, calculated, you will get 4.756. Okay, so you got your pKa. So this is your pKa. Now let us put the values. What is pH? Oh, okay, let us put the values in equation 1. So how much pH is given? 4.9. So 4.9 equals to pKa, which is 4.756 plus log salt concentration. What is the concentration of salt we have? This much of the sodium ethonate salt. So this is 1.2 divided by concentration of acid. Okay, subtract it. 4.9 minus 4.756 equals to log 1.2 acid concentration. Okay, so after subtracting it, what you will get? You will get basically 0.144 equals to log 1.2 divided by acid concentration. Okay, so how to solve this? Initially also I told you either take anti-log on both sides. If you are not able to take anti-log, you don't know how to take anti-log, it is basically shift plus log. So instead of taking, you can simply do 10 to the power 0.144 equals to 1.2 divided by acid concentration. So you can solve this way also. So you will get 1.393 equals to 1.2 divided by acid concentration. So concentration of acid would be 1.2 divided by 1.393, which comes out to be 0.861. Okay. I hope this is clear to you. Now let us move to the next question. Okay. So basically what they say here, a student prepared two solutions. Solution A was made by mixing 25 centimeter cube of 0.01 mole per decimeter cube aqueous sodium hydroxide with 50 centimeter cube 0.01 mole per decimeter cube of ethanoic acid. So solution A is buffer solution. And similarly, they have prepared the solution B. But what they are saying, solution B is not a buffer. So what you need to do, so I says what is meant by a buffer solution. I hope you can define a buffer solution. Okay, now for the II, what it says, explain why solution A is a buffer solution, whereas solution B is not. So we need to tell them that solution A is buffer. Why? Okay, let's solve this question. Okay, so first of all, what to do? Calculate the moles of everything. So you have sodium hydroxide, which is NaOH. So calculate the moles of NaOH. So NaOH, how much you have? 0.01 mole per decimeter cube in 25 centimeter cube. So how to calculate the moles? Basically, you know the formula. Molarity is equal to moles divided by volume times 1000, because the volume we have in ml. Okay, so molarity is 0.01 times volume, which is 25. Fine. And divide by 1000 equals to moles. Moles will come out to be 2.5 into 10 to the power negative 4. Similarly, calculate the moles of acetic acid. So this is for solution A. So we are doing for solution A first. So acetic acid, similarly, use the formula, what this much. So this is 0.01 into 50 divided by 1000. So it comes out to be 5 into 10 to the power negative 4. So if you see now, so what kind of reaction will take place? So you have acetic acid and sodium hydroxide. What reaction will take place? Acid-base reaction, sodium ethonate or sodium acetate would be formed plus water. So how many moles of acetic acid we have? We have 5 into 10 to the power negative 4. And for the sodium hydroxide, we have 2.5 into 10 to the power negative 4. So clearly here visible, the moles of sodium hydroxide are really less and moles of acetic acid are much more. So they are double basically. So what will happen? So only 2.5 into 10 to the power negative 4 sodium hydroxide will react with 2.5 into 10 to the power negative 4 of the acetic acid. Basically, if I need to simplify it, you can simply say there are 5 of the acetic acid and 2.5 of the sodium hydroxide. So out of these, only 2.5 will react. So here you will still have 2.5 left and here you just have 0 left. Okay. See, so now basically what will happen after the reaction? You will have 2.5 into 10 to the power negative 4 moles of the salt and still 2.5 into 10 to the power negative 4 of the acid left. So what this forms? So you have this in the solution and you have this in the solution. So what they form together? So they will form a acidic buffer. So acidic buffer formed. Correct? Fine. Hope this is clear. So there will be acid-base reaction. Sodium acetic acid will react with sodium hydroxide, giving sodium acetate, but only 2.5 moles since sodium hydroxide is a limiting reagent. So only 2.5 into 10 to the power negative 4 moles of the sodium hydroxide will react with 2.5 into 10 to the power negative 4 of the acetic acid. So excess acetic acid would be acid would be 5 into 10 to the power negative 4 minus 2.5 into 10 to the power negative 4. I hope this is clear. Now let us see the solution B. So solution A we are done. Now let us see solution B. I'll be solving it here. For solution B, calculate the moles basically. Calculate the moles of sodium hydroxide first. So moles of sodium hydroxide would be for NaOH. Oh, see, here they have given you the concentration. So it is 0.02 into 25 divided by 1000, which is 5 into 10 to the power negative 4. And for the acetic acid, how much? This much. It is 50 into 0.01 by 1000. So this is also equal to 5 into 10 to the power negative 4. So basically here you have the moles, in both the cases, the moles are equal. So basically this is also 5 into 10 to the power negative 4. This is also 5 into 10 to the power negative 4. So basically normal acid-base reaction will take place. Nothing will happen. No buffer would be formed. So what happens? Normal acid-base reaction or neutralization takes place. Acid-base reaction takes place. So what you will be having in the solution, you will just have sodium acetate. That's it, nothing else. Sodium acetate or sodium ethonate. You just have this much, this in the solution. Okay, no buffer would be formed for solution B. I hope this is clear. Okay, now let's move to the next question. So it says, which of the following solution when mixed would make a buffer with pH more than 7? Okay, so we have to make a buffer with pH more than 7. Let's see. Methanoic acid and sodium methonate. No. So methanoic acid, the solution would be acidic in nature. Acidic in nature because we have methanoic acid. Next, we have sodium hydroxide and sodium chloride. So, but here, if you see, this is a salt of strong base and strong acid. And this is a strong acid. So, it won't form any buffer. Next, we have ammonia and ammonium chloride. So, ammonia is basic in nature. And ammonium chloride is the salt of weak base and strong acid. Which strong acid, basically which weak base you can take? Ammonium hydroxide. And which strong acid you can take? HCl. Fine. And they can react together to form ammonium chloride, which is NaCl, NH4Cl plus water. Fine. So this buffer would be basic in nature. Why? Because ammonia is basic in nature. Hope this is clear. Okay. So this question, what is the approximate pH of the buffer containing this much moles of the weak acid? pKa value is given to you and salt concentration is also given to you. So they have given you the moles and you have to find the pH. So for this question, You need to do it, solve this question, think, solve it, and send the answer to wisdomscience25@gmail.com. I hope you liked the video. So there is one more thing. There is mechanism of buffer, like how buffers actually work. If you want to know that, just comment me. I will make another video on it. Okay. I hope you liked the video. If you like it, please subscribe and share. Okay. Bye-bye.